Hey everyone, in this video we're going to learn how to factor trinomials when a is not equal to 1. That means that the leading coefficient is a value other than 1. Maybe 2, maybe 3, could be 10. But those are the trinomials that we're going to learn how to factor in this video. But before we get to factoring, let's start with some multiplication. Find the product in standard form of the quantity 2x plus 5 times the quantity x minus 4. We'll start by distributing the 2x to both terms. So we have 2x squared minus 8x, and then we'll distribute the positive 5, so plus 5x minus 20. Combining our like terms, we get 2x squared minus 3x minus 20. Okay, so just like factoring trinomials when the leading coefficient was 1, our goal by the end of the video is to take a trinomial like 2x squared minus 3x minus 20 and come up with the factors, in this case, which are 2x plus 5 and x minus 4. So let's focus on this example in the reverse direction. So if we start with 2x squared minus 3x minus 20, that second step was 2x squared minus 8x plus 5x minus 20. Now, in order to factor an expression with 4 terms, we can use grouping. So we'll group the first 2 terms together and the second terms together. The greatest common factor of the first 2 terms is 2x, and then we have x minus 4 left. The greatest common factor of the second 2 terms is 5, and then we have x minus 4 left. So we can factor out the greatest common factor of x minus 4 from each term, and we'd be left with 2x plus 5. So although the factors are in a different order, commutative property of multiplication says that's okay. We can change the order of our factors, but we have the correct 2 factors. So how did we figure out to replace negative 3x with negative 8x plus 5x? Well, if we take the product of 2 and negative 20, we would get negative 40. And one of the factor pairs of negative 40, without listing them all out, is going to be negative 8 times 5. Right? There's many more factor pairs, but that is the factor pair that adds up to negative 3x. Okay, so how did we know to write negative 3x as negative 8x plus 5x? So negative 8 and 5 are factors of negative 40 that sum to negative 3. Okay, so same process as a trinomial with a leading coefficient of 1, but now, since our leading coefficient is not 1, it's going to change our product. But we still take the same approach. We find that factor pair that we can replace the middle term with, and then we use grouping. So just again to have a formal set of steps to refer back to, we'll use the trinomial 3x squared minus 13x plus 12 as our example, and we'll go through our steps. So we're going to start by multiplying the leading coefficient and the constant term. So 3 times 12 is 36. We'll list out the factor pairs of 36. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, and then we have the negation of each as well. So I'll make a second column. So we have negative 1 times negative 36, negative 2 times negative 18, negative 3 times negative 12, negative 4 times negative 9, and negative 6 times negative 6. So we need to select the factor pair that adds to negative 13. So that's going to be our factor pair here of negative 4 and negative 9. So we can rewrite the trinomial as 3x squared minus 4x minus 9x plus 12. And we can group, so we'll group the first two terms together and the second two terms together. Make sure I put a plus sign because I kept the -9 together. Greatest common factor of our first two terms is x. We're left with 3x minus 4. Greatest common factor of our second two terms is -3. And the reason we want to include that negative is because we want the factors to match. If this is 3x minus 4, we want it to match this factor here. So factoring out a negative with the 3 accomplishes that. We're left with 3x minus 4 then. 3x minus 4 is the greatest common factor in each term. So we can factor out 3x minus 4, and then x plus -3 we'll write as x minus 3. And as we saw with our trinomials when the leading coefficient was 1, if we had done minus 9x minus 4x, so reverse the order of the middle terms, we could still use grouping, just our factors would be in the opposite order. But again, doesn't matter by the commutative property of multiplication. So let's apply this technique to a few examples. Starting with 2x squared plus 9x minus 5. Okay, so we're going to multiply the leading coefficient with the constant and get -10. So we need factor pairs of -10. So we have 1 and -10. We have 2 and -5. -1 and +10. -2 and +5. So we need to choose the factor pair that adds to +9, which is our factor pair here. So we have 2x squared minus x plus 10x minus 5. And we can group the first two and the last two terms together. Taking the greatest common factor of the first two terms, factor out next, we'd be left with 2x minus 1. Second two terms, we can factor out a 5. We're left with 2x minus 1. Greatest common factor of each term is 2x minus 1. So factoring out 2x minus 1, and then we'd multiply it by x plus 5. So there are the factors of 2x squared plus 9x minus 5. And I know I've said it quite a bit in the videos on factoring, but we should always know our factors are correct if we have the time to multiply them back out. Again, leave that exercise for you to practice. Our next example, 2x squared minus x minus 6. So multiplying the leading coefficient with the constant term. So 2 times -6 is -12. Listing out our factor pairs of -12. Well, let's see, can we come up with the factor pairs of -12 that add up to -1 without listing them all out? So let's see, 4 and -3, maybe? Well, that adds to +1, so let's change it, -4 and +3. Well, that will do it, so I don't need to list out all the factor pairs. I already found one. So we can rewrite this as 2x squared minus 4x plus 3x minus 6. We'll group the first two terms together, second two terms together. Greatest common factor of the first two terms is 2x. We'd be left with x minus 2. Greatest common factor of the second two terms is 3. We're left with x minus 2. X minus 2 is the greatest common factor in each. So we'll factor out x minus 2 and be left with 2x plus 3. And there we have the factors of 2x squared minus x minus 6. Next up, 2x squared plus 15x plus 28. So 2 times 28 is 56. So again, can we come up with the factor pairs of 56 that add to 15 without listing them all out? So let's see. Well, we know 2 and 28 are a factor pair. That's not going to help. Let's see. 14 and 4. 14 times 4. No, that would be 18, not 15. Let's see. 8 and 7. 8 and 7 is 56. 8 plus 7 is 15. Perfect. So we got it on our second factor pair. Probably should have came up with 8 and 7 first. Not sure how I missed that, but it's all right. We found the factor pair. Don't always have to get it on the first try. So we can rewrite our trinomial as 2x squared plus 8x plus 7x plus 28. Group our first two terms together, our second two terms together. Greatest common factor of the first two terms is 2x. Then we have x plus 4. Greatest common factor of the second terms is 7. We'd have x plus 4. Greatest common factor of our two terms is x plus 4. So we'll factor out the x plus 4, and we'd be left with 2x plus 7. Perfect. Okay, next up. 3x squared plus 4x minus 20. So we have 3 and negative 20. So that multiplies to be negative 60. So we need factors of negative 60 that add to positive 4. Let's see, 10 and negative 6 multiplies negative 60. Does that do it? Yeah, that would add to positive 4. So we can rewrite it as 3x squared plus 10x minus 6x minus 20. Group our first two terms together, our second two terms together. Now because we included that minus sign, let's just not forget the plus in between our two factors, two terms. So the greatest common factor of the first two terms is just x, and we'd be left with 3x plus 10. Greatest common factor, so we need 3x plus 10, so we're going to have to factor out a negative. So let's factor out negative 2, and that would leave us with 3x plus 10. So 3x plus 10 is the greatest common factor of our two terms. So we'll factor out 3x plus 10, and we're left with x plus negative 2, which is x minus 2. Okay, so basically the same technique, now just that leading coefficient is not 1. The standard form of a quadratic expression is ax squared plus bx plus c. We've seen this before, but just a nice reminder. So if a or c are prime, we can use the guess and check method to factor more efficiently. Meaning, if either our leading coefficient or our constant term is prime, we should be able to guess and check the factors quicker than doing grouping. So let's look at an example to walk through this. So 3x squared plus 4x plus 1. Well, both a and c happen to be prime, so that's best case scenario. So if we need to multiply to 3x squared, well, one factor has to be 3x, and the other factor has to be x. And to multiply to 1, it's either positive 1 and positive 1, or negative 1 and negative 1. And we need to add to a positive term in the middle, so positive 1 and positive 1. So in this case, let's multiply it out to check. So we'd have 3x squared plus 3x plus x plus 1, which is 3x squared plus 4x plus 1. Perfect. So there are our factors. So see what we're trying to talk about here. If either the leading coefficient or the constant term is prime, probably easier to guess and check. If you're having trouble though, grouping is still a good method. Okay? And if you're stuck, it actually may be quicker to use grouping, especially when that leading coefficient's not 1, than trying to guess and check. But let's look at another example where we'll try to guess and check the factors. So we have 4x squared minus 27x minus 7. So the leading coefficient's not prime, but our constant is. So we'll actually build our factors in the reverse way. The only factors of 7 are 7 and 1. So those have to be the constants in our factors. Now we're multiplying to negative 7, so one's positive, one's negative, not sure which, so let's leave that alone. So now we can either have 2x and 2x or 4x and x. Okay, well let's try 2x and 2x first because we don't have to switch that if it's wrong. So 2x and 2x. So we have 14x and 2x. One would be positive, one would be negative. So I don't see a way with those terms to get negative 27x. Okay, so those are out. So let's try 4x and x. Okay, so we'd have 7x and 4x. Again, one has to be positive, one has to be negative. Don't see a way to get negative 27x. That's out. So let's try 4x and x. So we'd have 28x and x. Well, if we make that negative, so it's negative 28x and plus x, we get negative 27x. Now that took a little bit of time because I was walking you through the process, but as you get better at factoring, you're going to be able to start to see, okay, well 2x and 2x don't make sense, and be able to kind of streamline your guess and check method. Right? But again, if you look at this and go, there's no way I can come up with that. Well, try first, but if you get stuck, then go back to your grouping, right? Do 4 times negative 7, which is negative 28. Figure out a factor pair of negative 28 that adds to negative 27, and use our grouping technique. So factor the following polynomials. So if one of them is prime, let's do guess and check. If not, we'll do our grouping method. So 6x squared plus 7x plus 2. So our constant is prime. So we have 2 factors. Again, we'll build backwards. So 2 has only 2 and 1 as potential factors. Now 6x squared, so that could be 3x and 2x or 6x and x. Let's go 3x and 2x. So 3x, 2x. Well, we also know we're multiplying to a positive number and adding to a positive number, so we could have put our plus signs in too. Okay, so let's see. We'd have 4x and 3x, which adds to 7x. Perfect, that's it. We got it on the first shot. There are the 2 factors. Next up, 8x squared minus 14x plus 5. So again, we have a prime constant. So we'll build in the reverse. So we have 5 and we have 1. Now we're multiplying to a positive number, adding to a negative number, so they both have to be negative. We can be pretty sure about that. Now 8x squared, so that could be 8x and x, or 4x and 2x. Okay, so let's try 4x and 2x. Let's see what happens. So 4x and 2x. So that would be negative 10x, negative 4x, which is negative 14x, which is exactly what we want. And some of you may be thinking, well, you knew what the answer was. And honestly, I didn't. I didn't make an answer key because I wanted to go through this process the way you would. And it just so happened that I wanted to try 4x and 2x first. If we tried 8x and x, we would go through the cases, see that it didn't work, and then we would get to our 4x and 2x case. But again, if we get it right on the first try, we're done. So now we know how to factor a trinomial with a leading coefficient other than 1. We started with our grouping method, where we multiply the leading coefficient with the constant term, found the factor pair of that value that added to the middle term, created 4 terms, and used grouping. And then we noticed if either the leading coefficient or the constant term was prime, guess and check may be more efficient. And again, I want you to try it at least, and if you get stuck, then go back to the grouping method. But at this point, practice a few of these trinomials, factoring these trinomials, before heading over to part 2 of the video. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.